Welcome back to the HSF Introduction to Apptainer and Singularity. This episode is about Apptainer instances. How can I keep my container running in the background? What are the use cases for instances? You will learn to run containers in a detached mode, to keep services up, and to deploy instances via definition files. As we have studied in previous chapters, commands such as run and shell allocate Apptainer Singularity containers in the foreground, stopping any process running inside the container after logout. This behavior suits the use cases of container for executing interactive commands in a well-defined environment. But there are cases when running processes in the background is convenient. For example, when a web application like a Jupyter Notebook is deployed inside a container, it is desired to keep the container up while it waits for connections from the web browser. Apptainer provides the concept of instances to deploy services in the background, while Docker is a common choice of tool for setting services. Apptainer has the advantage of working without requiring any special permissions, like when you're working in a cluster provided by your university. In this chapter, we will learn the basics about the capabilities and some use case examples. Let's see how to start instances from an image file. To start an instance, Apptainer provides the command instance. To exemplify, let's pull the Alma Linux image used in the previous chapter. Or in the image. And then the image is started with the instance command. So after the instance name, after the image name, I will add the instance name. The .c file is the image, and my Alma9 is the name of the instance. Instead of opening a shell session, now the prompt is returning, and the image with the container are running in the background. To confirm that the instance is running, I can list it. And here is the container that's running in the background. To interact with the instance, the commands exec and shell are available. I can run and interact with the instance that's continuously running. The instance must be referred as instance name. For example, to open the instance that I just started, I will use the command Apptainer shell instance, and then point to the my Alma9 that I just named. And now I have a shell inside the running instance. Whenever I exit, the instance keeps running. If I want to stop the instance, I can stop it with the command stop. If I list the instances, now it's not running anymore. When I start an instance, I could use also all the other options. For example, if when I start the instance binding a local directory, I can use the bind command that we have seen in the previous chapters. Okay, here the source could not be mounted because the data directory is not existing inside the instance. So I could choose a different mount point. Actually, also the directory. Creating a directory. Now that after the creating the directory, I could bind it to the image. Stop the image again. Let's see a more interesting example. Let's make a web server as an instance. One of the main purposes of the Apptainer instances is deploying services with customized environments. Before moving to more complex use cases, let's start with a basic example, a web service showing an HTML page with a message. Let's write a basic index page. We can copy this content into a file. Well, actually, I have already the index file here edited with this content. So if you're not familiar with HTML and how to write a simple web page, you can look into this HTML tutorial here and find the basic commands that you can use. What matters basically is to have a simple page that can be shown by a server. Now let's prepare the basic web server, and we'll use the Python HTTP server. We want to create a definition file and save it in basic servers.dev. So in this file, we start using Docker Hub, and we'll download the Ubuntu 20.04 image. After that, we will start with the basic setup. apt-get is the program to install new packages. We want to update, and we will install Python 3.9. Then we use the pragma files to copy files from the outside to the inside of the container. And finally, we use that script that what this container will execute. So these are all commands that we have seen in the section about creating containers from definition files. Then I can build a container, and I will need to use fake root because the apt-get commands are privileged commands that only root can run. So I build a container, the Ubuntu is downloaded, and then the installation is starting. And the image file is created. Now I have to start the instance. I can copy the command from here, and I start the instance. And notice that the option that I'm using here, it's a no mount TMP. So I don't want to mount the temporary directory, since in this instance, I've been putting that file in container directory. So I don't want the external TMP to be there. So the instance started. Now I can test that the actual container is running and serving the web page by using the CLR command and downloading the index page. And here's the page that I wrote. Now, if I'm running locally, I could even start a web page, but actually even in this case where I'm running remotely, I could do that by creating an SSH tunnel. So I can, the web server on the remote server is on port 8850, and I can create an SSH tunnel here. To forward that port to my local laptop. So first I have to find out the name of the host. And then I'll be forwarding the ports from that host to mine. Now, if I go to my local web server and I start a new tab, I should be able to connect and see the Hello World page. Now let's see the instance. My web server is still running. Let's stop it. We don't need it anymore. So I can stop it. Let's see a more complicated example, something a little bit more useful. As an example of the capabilities of instance services, let's extend our definition file to deploy a Jupyter notebook to serve a container from a containerized environment. Jupyter notebooks are environments that include the code, the possibility to run text, and to do everything interactively through your web server. So we want to provide a Jupyter notebook that's ready to use root. So if you remember, our example from the definition files chapter was installing a container with root. At this point, it must be almost straightforward to extend and do it here. So let's start with the definition file. So let's call it Jupyter with root. Let's start from Ubuntu from Docker Hub as well. And after installing Python 3, we will install pip and use pip to install notebook. So notebooks are a package distributed via a Python distribution package pip. Then I'll be installing also a wget and installing root. At the end, I'll be defining the environment to export the variable required by root. And I'll be starting a notebook on port 8850. So to build this container, I need to be root, since I'm installing package with apt-get. Okay, I made a typo. Let's go back. On top of the file, I added that extra letter. Okay, let's try again. The building is starting. The Ubuntu image is already here, so it can go directly with the installation. So after the building of the image will complete, I will start an instance, this time named my notebook. So here is already the pip installation of the packages, installing the requirements for the notebook and then also the notebook. After the packages is downloading root. We should be close to the completion of the setup. The tarball, once expanded, then we'll have to set up the environment and save the image. The image is almost here. Now if I'm listing, I see also the Jupyter Notebook with root, and I can start the instance. List the instances. Now my notebook is running. If you go to the localhost 8850, now we'll have a notebook. So since I'm running on a remote server, we'll try to reload the page to 8850, and here is the notebook. So in order to start and log in, it will ask for a token. So I don't know what's the token, but I can log in my container to find that out. So I'll be using the command exec to list the Jupyter Notebook. Sorry, the notebook is called my notebook. Okay. Now this is the token that I have, and I can use it now and paste it in my web server. I go to the web server. I pass URL, and let's see. And here I have the notebook. Now I can start a notebook. I. 'Book. 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 'Bo in Python. And I will see if root is available. Import root. And then I will try a couple of commands. And see if they are working. It's running, and here is calculating the histogram. So the bottom line is that with any Jupyter notebook that you write, you can provide an Apptainer image that will set the environment required to execute the cells, will also contain all the prerequisites. And it doesn't matter if yourself or someone else comes in 1, 5, or 10 years, your code will work independently of the software available in your computer, as long as you can run Apptainer. Now, as an exercise, you could set up a Jupyter notebook with a server with uproot so that you can load a root file in Python. So you saw already the example before. You can install uproot using pip. And if you remember, pip is not a privileged command. So you will not need to use a fake root. Anyway, I'll leave this up to you, and please try to find your solution before looking for the one here in the episode. So to summarize, you have seen how instances allow to set up services via Apptainer images or definition files. And the code provided in Jupyter Notebooks can be accompanied by an Apptainer image with the environment needed for its execution, ensuring the reproducibility of the results. Thank you.